Assalamu alaikum, cadets. Sabah al khair, good morning. I hope you have a cup of tea or a cup of coffee with you this morning. This lesson is quadratic functions part 2. First this morning, we'll go through question 2.7.1. Let's review here real quick. There's several different forms you can find. There's a third form too, but the two forms we'll focus on today, if my camera will focus here. Not sure why the camera keeps going out of focus. Apologize for that. I have to figure that one out. Okay, the quadratic form, ax squared plus bx plus c, and then the vertex form, which is really helpful for graphing, and you'll see in just a moment. So if you need more help, feel free to go to Khan Academy, okay? And then you can put Khan Academy vertex form, and he has a bunch of lessons, and he's more experienced than I am. But I'll teach you straight to this here. All right, let's look at this first one, 2.7.1. Where are each of these, and what happens with the 4, minus 4 here, minus 4 outside the brackets, a 4 times the x squared, adding a 4 inside the bracket, and adding a 4 outside the bracket. Okay, let's think about this. Think about this, okay? We know this is a parabola, graphing a parabola, because it's x squared. If I square everything inside the bracket, y can never be less than 0. Y can never, whatever I put in here, whether it's negative or positive, I square it, I get a positive answer for y. So my minimum value, let's start talking about minimum and maximum as we analyze functions. My minimum value can never be less than 0. My minimum y value, my minimum f of x, the lowest my graph will go will be 0, y equals 0. Well, where is that? Well, it would be where this is 0. 0 squared is 0, right? So where would that be? Well, what minus 4 equals 0? 4. Okay, so if I'm thinking about my parent function, y equals x squared, with the vertex at 0, 0, opening up, these are all opening up because it's all positive, right? Everything has to be above 0 for this one. So this, if I put a 4 in for x, that's where I'll get 0 for y. So I'm moving y equals x squared 4 units to the right. Okay, and that matches what we know about y equals x minus h squared. That right there, there's my h. The 4 is my h. So, and then my vertex is at h comma k. So two ways of looking at it. Think about it here with your minimum value idea. Well, when I put in 4, that's when I get the 0 for y. So I've moved y equals x squared 4 units to the right when it's a minus. Okay, now let's look at it. I'm already getting a little long here. I realize this is a long video. What happens here? Well, I have the minus 4 outside the brackets, so let's think about it. Like once again, when we think about this right here, no matter if I put a negative value in for x or positive value, I always get positive or 0. The lowest I can go is 0, right? My minimum value for y is 0. If I put a negative in here, I get a positive y. If I put 0, I get 0. If I get a positive in for x, I get a positive y. I never get a negative value for y. My minimum value for y is 0. And then I subtract 4. So I move the graph down 4. Okay, I move y equals x squared down 4. Move it here, I'm right 4. Here I'm down 4. What does this do? Every value of, you could try it yourself, y equals, parent function, y equals x squared. Well, if I go to 1, normally I'd put in a 1 here, I'd get 1 squared is 1. Now I put a 1 in here, 1 squared is 1. times 4. I have a vertical stretch. Every point gets stretched. Stretch, vertical stretch, by a factor of 4. Okay, ooh, this is the longest video I've ever made. Sorry, guys. Here we got, once again, how can I make this 0? I know that my minimum value for y will be 0. How do I get 0 in here? Minus 4 plus 4. So this takes my parent function, y equals x squared, and moves it over to x equals negative 4. So now I'm going to move the parent function, I move it left 4, and this, of course, I will move it up 4.